When I saw this picture, I immediately remembered Arthur C. Clarke, the famous English sci-fi writer and author of 2001: Space Odyssey, when he said, "Two possibilities exist, either we are alone in the universe or we are not. Both are equally terrifying." The image before you now is the first color image of the universe published by the new James Webb Telescope, which is supposed to replace Hubble, the most famous telescope known to the public. This picture was published on July 11th at a NASA conference in the presence of U.S. President Joe Biden. I will try to make you imagine this picture in its simplest form. Each bright spot in the image is a whole galaxy with its stars, suns, planets, moons, black holes, comets, asteroids, and all the celestial bodies you know in our galaxy. These bright spots are not stars, but rather entire galaxies. We could not before that know their existence or see them because of the low accuracy of the Hubble telescope compared to the lenses of James Webb. What you see in the picture is hardly more than the size of a grain of sand in the hand of a person standing on the ground, carrying this grain from above, as NASA describes it. But what does this analogy actually mean? Imagine that you have brought a ladder, climbed up to the white ceiling of your room, and drew just a minute point with the tip of a pen on the towering whiteness of the ceiling. This trivial point you just drew contains all the galaxies you can now see in the picture. Imagine how many other tiny points you can draw side by side, almost an infinite number. This is the size of the universe that we see with its galaxies, and we saw a small part of it in the picture. Isn't it scary? Thousands of galaxies NASA were able to observe in the first image revealed by James Webb Telescope using infrared radiation on a galaxy cluster known by astronomers as SMACS 0723. NASA were able to obtain this image using several filters of different wavelengths, which gathered in the final image that you see now. This telescope contains a wheel on which a set of filters are installed. Each filter receives one specific wavelength of the light falling on it from the galaxies. It is monochromatic, meaning that it sees only one color and blocks the rest of the other colors so that it can bring all the possible details of this color. In the end, all these filters combine all the wavelengths into a single color image as you see it. This image shows us what a galaxy cluster looked like 4.6 billion years ago, meaning that what you see now is literally the past of the universe. The James Webb Telescope works in a way similar to the work of the human eye, in that it collects the light falling on it, analyzes it, and translates it into an understandable image. That is, we were able to see the galaxies in the picture because the light from them traveled through space for millions of light years until the James Webb Telescope picked it up and translated it into images that we can perceive. In fact, the light came out of these galaxies 4.6 billion years ago with the emergence of the Earth itself, if not before the Earth originally existed. This light continued on its journey, covering millions of light years. Within that, the Earth was created and life appeared, then billions of years passed, until we humans appeared and inhabited the Earth, and then we built this telescope to capture this light and show us what the past of this space point looked like. That is, these galaxies that you see are not located in the same places now, but it is possible that some of them have disappeared or collided with others. Imagine you and I standing at a distance of 10 meters from each other. I am standing at point A, for example, and you are standing at point B. I have a ball in my hand that I want to throw for you to catch. The moment I throw the ball in the air towards you, I move from my place to another point and let it be C. Until the ball crosses the distance from point A to point B and reaches you, you will be looking at me but not seeing me, because I will have come some distance and reached point C, so far away from point A that the ball came out from and became past for you. This is exactly what happens in space.